Good morning, children. Welcome to our chemistry online class. In last class, we discussed about the covalent bond and covalent compounds, and there we have seen the Lewis structure of covalent compounds. So, in today's class, we are going to learn about how to draw Lewis structure. In order to draw the Lewis structure, there are 5 steps. These are very important. So using these steps, we can draw the Lewis structure of any compound. So the Lewis structure is very important. So let's see how to draw Lewis structure. So we know the Lewis dot structure provide a picture of bonding in molecules and ions in terms of shared pair of electrons and the octet rule. So the steps are, the first step is we have to calculate the total number of electrons required for writing the structure. Okay, how to find out the total number of valence electron? For example, if a molecule having 2 atoms, that is, for example, if we are taking HCl, we have to find out the valence electron in the hydrogen and the valence electron in the chlorine. For hydrogen it is 1, chlorine it is 7. So and we have to add, that is 1 plus 7 will get 8. So the first step is we have to find out the total number of valence electron of each atom. The step and if the compound having, if the compound is ion which carrying charge, for example if it is an anion, it will carry one negative charge. So what we will do, we have to find out the valence electron in the compound. For example, if we take cyanide, it is an ion, we know that it's an ion, it is also carrying one minus charge. So how to find out the valence electron here? Carbon. So we have to first find out the valence electron in the carbon, that is 4 plus, we have to find a total. So 4 plus, how many valence electron does nitrogen having? It's 5. 4 5 plus 5 plus, it's carrying one negative charge. So if it is minus charge, we have to add 1. So we'll get total 10 electron. This is the total number of valence electron, 10. If it is carrying plus charge, that we have to do, what we'll do, we have to do minus 1. If it is only 1 charge, then plus 1. If it is 2, plus 2. If it is 3, plus 3, like that it will go. The next step is one must know the chemical symbols of the combining atoms and their skeletal structure. For example, if we have to draw the HCl molecule, we should know what are the constituents in it, the chemical symbols of each atom, that is HCl, H and Cl. This is a skeleton. It will be a skeleton for this. Then in general, the least electronegative atom occupies the central position. So we have to find out which is the less electronegative. If in HCl, if we compare chlorine with hydrogen, chlorine is more electronegative. So that for that we need to know about the periodic table. In periodic table, the elements which is near to fluorine, those are very electronegative. And if we move from left to right in the periodic table, the electronegativity increases. So hydrogen always will be the central atom, because hydrogen, if a compound contain hydrogen, it will be always central atom because it is the least electronegative in the periodic table. So it will attain the central position. And there is one more trick. For example, if like molecules like this, which will be in the central, which having the less number, that will be in the center. For example, here 3 chlorine are there, only 1 phosphorus is there. So phosphorus will be in the center. Like this we have to draw. Okay. Then After accounting for shared pair of electrons for single bonds, the remaining electropairs are either utilized for multiple bonding or remain as lone pairs. And then the next step is we have to draw the bonding molecules like this. That is, each bond represented by 2 electrons. Then we have to distribute the other valence electron, either it by the lone pairs like this, or else we can utilize it as bonds. Here you can see some more examples. Here hydrogen fluoride, the valence electron of hydrogen is 1, for fluorine it is 7, and we have to find out the total, so it is 8. The next step we have to draw the single bond between the hydrogen and fluorine. So single bond we have to draw, the single bond having 2 electrons, it is denoting 2 electrons. So we have to find out the remaining electrons, that is 8 minus 2, that is 6. And we know hydrogen already distributed its 1 electron, then the remaining electron we have to distribute it to the fluorine as lone pairs of electrons. So 1, 2, 3, 4, 5, 6. So this will be the structure of fluorine. And if you check, hydrogen having 2 electrons, oxygen, fluorine having 8 electrons. Fine. Similarly, we can draw the structure of nitrogen. For example, N2 molecule, 1 nitrogen having 5, so total 10. Next step is we have to draw a single bond. So 10 minus 2, that is 8. So how can we distribute this 8 electrons? So we know already it is distributed 2 electrons, remaining 3 electrons will be there. So we have to distribute the 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. Like that method we can distribute. Either in the form of bond also we can distribute. Nitrogen only carry 2 lone pairs. We'll see
a Lewis structure for covalent molecule. So for example, we'll take CCl4. So the first step is we have to calculate the total of valence electron. So first we'll start from carbon. The number of valence electron of carbon is 4. So 4 plus number of valence electron in the chlorine is 7, but there are 4 atoms, so 7 into 4. So what will be the total? It is 4 plus 28, that is 32. So there are 32 valence electron. So we have to equally distribute this valence electron. So the second step is we have to draw the Lewis structure. For that we have to put the least electronegative atom in the center. So which is the least electronegative in carbon and compared to carbon and chlorine? There carbon is the least electronegative. We know chlorine is highly electronegative. It is near to fluorine. And one more easy method is there to find out the central atom, which is less number, that will be the central atom. For example, here you can see 1 carbon and 4 chlorine. So carbon is least number, so it should put in the center. For example, if you take PCl3 molecule, phosphorus should be put in the center. And we have to draw chlorine. These are outer atoms. And the next step is we have to draw the bond, that is each bond representing 2 electrons. So we have to distribute 2 electrons each for each atoms, that is for chlorine 2, 2, 2, 2. So 32 minus, so we have distributed 1, 2, 3, 4, 5, 6, 7, 8 electrons. So 32 minus 8, that is 24. Then we have to distribute this 24 electrons to the outer atoms. So how to distribute this one? For each atom we have to distribute equal amount. So there are 24, so each atom will get 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So let's see if it is completing its octet or not. So let's start from chlorine. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. It is completed its octet. What about this chlorine? This also completed its octet. What about this chlorine? It is also completed its octet. Here also we can see it is completed its octet. What about the carbon? Carbon, 1, 2, 3, 4, 5, 6, 7, 8. So carbon also completed its octet. So this will be the Lewis structure of CCl4. And this we can represent in another method, by bond method. Carbon in the center, and to each electron or each bond we can represent by this line. And each electron we have to draw the non-bonded electrons, we have to show like this. There are 6 non-bonded electrons for each atom that we have to show like this. This is the Lewis structure. Okay, I hope all of you understood how to draw a Lewis structure. So let's see in next topic. One more example, that is O2 molecule. O2 molecule. How to draw the structure of O2? First step is we have to find out the total number of valence electron. So it is oxygen. So each oxygen having 6 valence electrons. So there are 2. That's why 6 plus 6 it is 12. It is carrying 12 electrons. So we have to distribute this 12 electrons. So then the second step is we have to draw the skeleton. So one oxygen, another oxygen, and the third step is we have to distribute the bond. So each bond denoting by 2 electrons. So 2. Then we have to distribute our remaining electrons. So 12 minus 2, that is 10. We have to distribute 10 electrons. So we'll start from this one. 1, 2, 3, 4, 5, 6. Then how many electrons are remaining? 10 minus 6, that is 4. So 1, 2, 3, 4. Then let's check the valency, or let's check if it is octet is completing or not. Check this oxygen. 1, 2, 3, 4, 5, 6, 7, 8. So it is completed its octet. It is happy. What about this oxygen? It is 1, 2, 3, 4, 5, 6. So it is not obeying the octet rule. So what we can do? We can do one thing. From here, these 2 electrons can shift from here. And this is again it is a fifth rule, that is from the outer atom we can shift electron towards the central atom, and it can make as a bond. For example we can see here. Let's see, oxygen, 2 electrons, 1, 2, 3, 4, 1, 2, 3, 4. If from here we can shift here, then let's count, or let's see whether it is satisfying octet or not. We'll take the first oxygen. So 1, 2, 3, 4, 5, 6, 7, 8. What about this oxygen? Also 1, 2, 3, 4, 5, 6, 7, 8. So both are happy, both having completed octet. So both are happy. Okay. So how can we represent these 4 electrons? We can represent this 4 electron by another method, another way. So there are 4 electrons. So each 2 electrons showing single bond. Similarly, we can by this double bond or double bond O. Remaining electrons can draw like this. So this will be the structure of